Hello everybody, I welcome you all to NCAS geology class. In my previous video, I have discussed about the plotting of the rho and phi angles in the stereonet to find out the stereographic projection of the crystal model. Now we can take use of the interfacial angles directly to find out the stereographic projection of crystal models. For example, I can take a model which is made up of cube octahedron dodecahedron that I will project. And so how this projection is being made, let us discuss. So in stereo projection, the elements, these symmetry elements, the crystal axis and the faces can be transferred, can be displayed in the stereographic projection. The axis are shown by arrows. The axis are shown by. So to show the axis, the arrows are being used in the stereographic projection plane, A axis, B axis, C axis, and the axis of 2-fold, 3-fold, 4-fold, 6-fold, axis of rotoinversion. They are used. They are represented through different symbols. So if this is the equatorial plane, we show the axis through arrows. This is A axis, this is B axis, this is C axis. And the axis of two-fold symmetry, if this axis is axis of two-fold symmetry, then this will be, these ovals are being used to represent two-fold axis, triangles, three-fold axis, squares, four-fold axis. These hexagonal shaped diagram is used to give a six-fold axis, to represent six-fold axis. Similarly, three-fold rotoinversion axis, this is four-fold rotoinversion axis, six-fold rotoinversion axis. These are the symbols which are being used. The planes of symmetry are shown by solid straight lines or by solid arcs or by solid circles. If it is horizontal plane of symmetry, then it is shown by the primitive circle. So this is the primitive circle. Let us say this is the primitive circle, and this circle is made solid to represent horizontal plane of symmetry. If we have the vertical plane of symmetry, it will be a straight line. It will be a straight line like this. It will be a straight line like this, or it will be a straight line like this. It will be a straight line like this. Solid straight line, they will indicate planes of symmetry, and straight lines indicate vertical planes. Inclined planes, they are shown by arcs, the inclined planes. But solid means it is a plane of symmetry. So plane of symmetries are indicated by solid lines. And the poles of the faces of the upper half of the crystal in the upper hemisphere are shown by solid dots, and the poles of faces which are occurring in the lower half, they are shown by open dots. A solid dot is found to surrounded by open dot in that case where the face occurring on the upper hemisphere is found to be superimposed over the corresponding face on the lower hemisphere. there we see that this symbol is being used. This is for the face on the upper hemisphere, this is for the face on the lower hemisphere. The great circles of stereographic net are used to represent interfacial angles made by faces with not one face. Interfacial angles, this stereographic net is used, so this face is used to find out the interfacial angle through great circles. Small circles of the net are used to represent faces that make angle with the faces located on the primitive circle, mostly from not one face. Not one face is taken as the 0 point. So let us see, this is the crystal model which is to be projected into the stereographic net. So first we have to find out its spherical projection. From the poles of the faces, we join the south pole. The point where these poles of the faces pierce the equator plane, that gives rise to the locus of those faces, and all the faces when they are transferred to this equator plane, they together constitute the stereographic projection of the supplied crystal. So here we have a combination form made of cube, octahedron and dodecahedron. Its interfacial angles, cube versus round dodecahedron is 45 degree, cube versus octahedron is 55 degree, dodecahedron plus octahedron they are 35 degree, and this interfacial angle is fixed for the cubic crystals. And let us say this is the crystal model, how it can be plotted in the stereo diagram. So primitive first, before you start, we first draw the primitive circle is drawn first. The net is being, this is the net, over it the overlay is fixed at the thumbtack, and this circle is being drawn. This is the primitive circle. This circle is made solid because this crystal model is having horizontal plane of symmetry. So this is solid. If this horizontal plane of symmetry would not have been there, then this equatorial circle would have been dotted. Then its north, south, east, west points are being marked over it to indicate the axis. This is the axis for A, A2, this is the axis for A1, and this is for vertical axis A3. So A3 passes to the center. So this is the equatorial plane. This is the A3 which is vertical. This A1 is horizontal from front to back. A2 sideways from one side to the other. A2. The A1, A2 they are horizontal. So they are shown by arrows. The poles of the faces, these faces, these are the vertical faces. They are parallel. The vertical face, they are located on this primitive circle. So this is for 0, 1, 0 face. This is for 0, 1 bar 0 face. This is for 1, 0, 0 face. This is for 1 bar 0, 0 face, and this is for the top face, which is coming at the center. This is 0, 0, 1 face. So all these are the faces of the cube. They have been transferred to this equatorial plane. So if you see a cube crystal is of like this shape. So this is 0, 1, 0 face. This is 0, 1 bar 0 face. The back is 1 bar 0, 0 face. Front is 1, 0, 0 face. This is 0, 0, 1 face. This is 0, 0, 1 bar face. This face will be, this is the equatorial plane. This face will be coming over here. This face will be coming over here. This face will be coming over at this point. This face, the front face, 1, 0, 0 face will be coming over here, and the not 1 bar not face will be coming over here. So this is 1 bar not 1 not 1 not 1 bar not. This is not 1. So all the 5 faces of the cube, they have been shown. and the bottom face is shown in a bracket which is superimposed. This face is superimposed over this face, so we can say, we can draw a circle like this to represent the bottom face. So this location is for not 1 and not 1 bar face. So all the cube faces of the supplied crystal model, all the cube faces have been plotted. Now we take into account the dodecahedral face. Dodecahedral face, they make 45-degree angle with the cube face, 45-degree angle with the cube face. So there are 4 vertical faces, 4 vertical rhomb dodecahedral faces, and they make 45 degree with the cube faces. So these are the position of cube face, cube face, cube face, cube face. So from here 45 degree, from here 45 degree one face, here 45 degree another face, here 45 another face, here 45 degree. These are the 4 vertical rhomb dodecahedral faces located on the primitive circle. There are 4 rhomb dodecahedral faces which are occurring in this way, in this position. In this position, these faces are occurring. In this position, the faces are occurring. In this phase they are occurring. In this phase they are occurring. So this angle is 45 degree. This angle is 45. This angle is 45. This angle is 45 degree. And they will be on the, they will lie on this horizontal line, horizontal axis. They will be somewhere here, somewhere here, somewhere here, somewhere here. 4 points from this center. This face is at the center. So this face is making 45 degree angle. This angle, this angle, this angle, this angle. So from here 45 degree, from here 45 degree, from here 45 degree, from here 45 degree. These are the 4 faces of rhomb dodecahedron which are occurring in the upper hemisphere. They are transferred to the, so these are the points, these are the points, these are the points. So this angle is 45 degree, this angle is 45 degree, this angle is 45, this angle is 45 degree. So we can draw this circle, we can draw this circle, we can draw this circle, we can draw this circle. Look at these faces, 45 degree portion, 45 degree portion. The lower 4 rhomb dodecahedral faces, they are superimposed over the upper 4 rhomb dodecahedral faces. So here we can say they are located, they are located here, they are located here, they are located here. So this is solid. Open dot is the face occurring at the lower hemisphere. They should get superimposed over one another. That's why there they occur. So in this manner, all the 12 faces of the rhomb dodecahedron are transferred to the equatorial plane or to the stereophilic projection plane. Now we have the cubic faces. Cubic faces, they make angle 55 degree. Faces. Now we will discuss about the plotting of the octahedron face, not cube. Octahedron face, in the octahedron is having face symbol 1 1 1 because it is cutting all the 3 axes at a unit distance, and these faces, they make 55 degree angle with the cube face. So if you consider cube face 1 0 with that of the octahedron faces, there are 2 octahedron faces at 55 degree angle with respect to 1 0 face. This is 1 0 face. On both sides, the 2 octahedron faces are there. So one is on the northeast, the other is in northwest. But this angle with the cube face Angle of cube with octahedron is 55 degree. So a 55-degree circle is being drawn, keeping this at the center. One not at the center or at the south pole. We take the 55-degree angle and draw the circle. This is the circle drawn. So somewhere over this circle, this 1 phase is occurring. So how can we locate the exact position? Then we have to see the angle that this phase makes with this rhomb dodecahedron, because here it is a position of rhomb dodecahedron. We know if we take into the interfacial angle, the cube rhomb dodecahedron angle is about 35 degree. Octahedron dodecahedron angle is 35 degree. So we know the location of dodecahedron is here. So here is the cube face. So this angle is 35, So keeping these two at the center, 35 circles are being drawn. 55 circles are there. So the point of intersection of these circles give the position of the octahedral faces. That has been shown here. So this is the position. This is the position of here. Dodecahedral face 35 degree. Dodecahedral face 35 degree circle. This circle can be drawn not at this position. This point will have to be brought to the south pole of the underlay. Then the angle is this small circle is being chosen for 35 degree. Then the circle is being drawn. So this point will have to be brought over here. This point will have to be brought over here, so that this circle can be drawn. So these are the intersection points. So they are the position of the octahedral faces. Similarly, we can draw the octahedral faces for the other two. And so these are the four upper faces which can be plotted to the stereographic net. In the lower faces, they are superimposed over these faces. So they occur below it. So we can say we can show them through circles. Thus we transfer all the faces of the cube, octahedron and dodecahedron to the equatorial plane. So in the equatorial plane we have faces location like this. This is 0 0 1 0 1 0 face. This is 0 1 bar 0 face. This is 1 bar 0 0 face. This is 1 0 0 face. This is 0 0 1 face. Here we have the dodecahedral faces. Here the dodecahedral faces. Here octahedral face. So in this manner, all the faces are being transferred. So this face will have symbol 1 naught 1 1 naught. This face symbol will have 1 1 naught. This symbol of dodecahedron will be 1 bar naught. This will be having symbol 1 bar 1 naught. Similarly, we can give the symbol for the inside faces. Now plotting of faces in the stereo diagram has been complete. The next part is we have to transfer the symmetry elements, which is important component of stereographic projection. We have to transfer the symmetry elements of the crystal concerned to the plane of projection. So how the symmetry elements can be transferred, let me discuss. We have this is a cubic crystal. We know cubic crystal is noted for 9 planes, 13 axes and 1 center. So we will show these symmetry elements in the stereographic net. So let me show. First we have to show the axis. So this is the A2 axis, and this A2 axis is the axis of fold symmetry. Let me give the cubic crystal. cubic features. So this is one axis, this is one axis, this is one axis. A2, A1, this is A3. So this axis is one axis of 4-pole symmetry. So this is this 4-pole symmetry symbol. A2 axis 4-pole symmetry, A1 symmetry, it is a 4-pole axis. So this is 4-pole A1 axis. This is A3 axis, this is 4-pole axis. This is shown at the center. So 3 axes of 4-pole that has been shown. Then there are 4 axes of 3-pole. 4 axes 3-pole, these are the 3-pole axes. These are the 3-pole axes. The corners. Or here the octahedral faces of octahedron they occur. So perpendicular to the octahedron face, they give rise to the axis of 3-pole rotor motion axis. So they are located not at the periphery, not at the center, they are located. So in the corner, in between this at the 45 degree position. So this is the line. So this is the position. This is the position for octahedron face. If we draw a circle like triangle like this is axis of this one, this one, this one, this one. So the axis will be oriented inclinedly. It will not be vertical, it will not be horizontal, it will be inclined. So this is position of one axis, this is position of one axis, this is position of one axis, this is position of one axis. They are the 4 axes of 3-pole rotor inversion. They have been shown here. So these are the 3-pole axis, 3-pole rotor inversion axis. Then we have the 2-pole axis. There are 6 axes of 2-pole which join the center of opposite edges of this opposite edges. If this is a key face, so this face, this is your axis of 2-pole symmetry. This edge, this axis of 2-pole symmetry. This edge, 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 axis of 2-pole symmetry. So like this we will have 6 axis of 2-pole. So if we take into account, we have this will be the location of a 6-pole axis. 6-pole, no, sorry, this is the axis of 2-pole symmetry. Axis of 2-pole, the 6 edges, 6 opposite, there are 12 edges. So 6 pairs of edges. So each pair will correspond to axis of, this axis will be axis of 2-pole symmetry. This will be axis of 2-pole symmetry. So this will be an axis of 2-pole symmetry. This is axis of 2-pole symmetry. This axis here, inclinedly axis of 2-pole symmetry. This is inclinedly axis of 2-pole symmetry. So this axis is 2-pole symmetry. This axis is 2-pole symmetry. They are vertical. These two are vertical. But this is inclined. This is inclined. If we see that these faces they come in one zone. 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 This vertical, this octahedral face, dodecahedral face, octahedral face, dodecahedral face, cube, octahedron, dodecahedron, cube, they come in one zone. So this is the zones. So now we have plotted the axis, then we have to plot the planes. So let us see the planes. This is one plane. This plane has been shown by this solid, this primitive circle. This plane has been shown by this solid line. This plane has been shown by this line. So we have three solid lines, axial. We have three solid lines, this line, and this line. They represent three planes of symmetry, mutually perpendicular. Three planes of symmetry which are axial and they are mutually perpendicular. This is primitive circle for vertical, for horizontal axis, horizontal plane of symmetry. This is vertical, this is vertical. So these are the two vertical planes, this is the horizontal plane. So these are three planes. Then we have the six diagonal planes. What are the six diagonal planes? We have two planes which bisect the crystal axis, horizontal crystal axis. So these are the two axial, they are vertical. So this line is solid, this line is solid. Besides these, we have four inclined planes. Four inclined planes. Let me show those inclined planes in the cube. This is the inclined plane. This is the inclined plane. This plane. This plane. These are the inclined plane. They divide the crystal into two equal halves. So they are the planes of symmetry. So these planes, then this plane, this plane. So these are the planes. These are the planes. These are the four planes. These are the two planes, six planes. This plane, this plane, this plane, they are the three planes. So there are total 9 planes of symmetry which have been shown here. This is one plane. This is one plane of symmetry. This is one plane of symmetry. This is one plane of symmetry. This is one plane. This is one plane of symmetry. 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 In this manner, there are 9 planes. So 9 planes, 13 axes, and it is having one center. Center, because of presence of the superimposed faces, it is, because how we define center of symmetry? Center of symmetry is defined at the point inside the crystal so that the faces, edges and solid angles occur in opposite directions at equal distance from the center. So as we see, the faces are superimposed. So the faces occur in opposite direction at same distance from the center. So it has a plane of, it has a center of symmetry. So all the symmetry elements are transferred, all the faces are transferred to the equatorial plane, and in this manner the projection of crystals are being made to the equatorial plane, or we can say this is the way how stereographic projection of crystal models are being done to show the faces and symmetry elements. So this is all about the projection of crystals, and in my next video I will simply show the 32 classes, their symmetry elements and their stereo diagrams. Thank you all for giving a patient hearing to my talk.